Okay, another problem. Let's say that I walk 5 miles to the east and 8 miles north. You start at the same point I do and walk in a straight line until we meet. You figure out where I'm going to be when I'm done and you walk a straight line. You don't have to walk as fast as I do because you don't go as far. Now, what distance and angle with east should you use in order to get to the finish point? Well, here's a picture. I walk 5 miles east and 8 miles north. There's a right angle here. You walk some unknown distance at some unknown angle and meet me. We start at the same point. We end up at the same point. Now actually the triangle tells us about everything we need to know. If we regard this as the x component of this vector and this is the y component, then we can see that the distance, which is the magnitude of the vector delta s, and notice I'm using delta s with a vector over it, with an arrow over it to indicate that it's a vector. Delta s meaning your displacement from here to there. Okay, the distance is the magnitude of that vector, which will be the sum of the square root of the sum of the squares of the components, which comes out to be 9.4 miles. The angle with which you move, or the angle at which you move with respect to east, will be the inverse tangent of the y component over the x component, which is 58 degrees measured counterclockwise from the easterly direction.